Welcome to a video on this example of a medication that is being titrated or adjusted. When I am reading the problem, I want to be paying attention to what is the ordered dose, the dosage strength, the desired physiological effect, and the patient info. So first I read 400 milligrams of dopamine in 250 milliliters of D5W is ordered. Immediately, I recognize that first information as the dosage strength. So that is telling me there are 400 milligrams in my IV bag. There are 250 milliliters in my IV bag. So I am jotting that information down. As I continue at the end of the first line, is ordered to maintain a systolic blood pressure of 100 to 200 millimeters of mercury. So the physiological effect is to maintain systolic blood pressure between 100 and 120. Again, making note of that information, trying to make sense of the problem as I go. Then it tells me the normal dosage range is 2 to 20 micrograms per kilogram per minute. So that is part of my order, and it is some of that math that I will use at some point. So I'm going to put it as part of my order that the range that I may adjust within is 2 to 20, and the labels on that are micrograms per kilogram per minute. I'm going to take a moment and see if I can adjust where my pen slipped. And so I keep reading. The doctor ordered the titration to begin at 5 micrograms per kilogram per minute. So that's really important because I have that word order there, and that is my starting amount. So that is 5 micrograms per kilogram per minute. And that's how I'll set up my IV to deliver that amount. Then I read about my patient that he is a 5'9" male. So that's 5'9" male and 230 pounds. I can tell from what I've already written down that I'm going to need to change the pounds into kilograms, but I'm going to finish reading before I start doing any math. So getting down to the last line, it says the recommended titration for the dopamine is 2.5 micrograms per kilogram per minute at 10 to 30 minute intervals. So I know this word titration means to adjust. So the adjustment is to be by 2.5 micrograms per kilogram per minute. And so we know that when we adjust either up or down, that's add or subtract, and we have to match up labels. So I could, if I start at 5, I could then add or subtract the 2.5 to adjust up or down. And the 10 to 30 minute intervals is sometimes confusing because this adjustment amount is per minute, and that's because we're adjusting the rate, but we may only adjust the rate after 10 to 30 minutes. So since this med is being monitored and adjusted based on blood pressure, we would have a blood pressure cuff on our patient. We would have that set up to automatically be taking their blood pressure frequently. And we would be seeing those readouts on a monitor near the patient's bed. And so then based on that readout, if their systolic blood pressure is not yet in the 100 to 120 range, we would be increasing their med or decreasing their med based on which way we want that blood pressure to go. So that's the reading, and I have organized all of my information. So now I'm ready to start my math, and the first piece of math that I need to do is to take the 230 and divide it by 2.2 to convert it over to kilograms. So divided by 2.2 is equal to 104.5 kilograms. And since this is an adult, we are dealing with a weight rounded to tenths. And we have talked about that it is only under 10 kilograms that we would round differently. So the first question they ask me is the minimum. So looking back at my order, the minimum would be referring to the smallest number in the range. So my smallest number in the range is 2 micrograms. And in the denominator of that are kilograms and minutes. I am asked for a milliliter per hour rate, so I want to do dimensional analysis to get to milliliters per hour. The order that I do these conversions does not matter. I just have to have all of them. So personally, I typically will deal with the weight first. So I'm going to multiply by 104.5 kilograms, and I put that over a placeholder 1, and that cancels kilograms. I set up for my next conversion, and going back and looking at my original, I need to change micrograms into milligrams. And I know that because I wrote down the strength and that was in milligrams. So one of the conversions I've memorized is that there are 1,000 micrograms to 1 milligram. And I'm setting that up with micrograms in the denominator. And then I want to cancel milligrams. And this is where I will use this dosage strength. The 400 milligrams will have to go in the denominator. And the 250 milliliters is also in that IV bag, so part of the same fraction. Milligrams is canceled. I will often circle. So here is milliliters. That is part of my answer. I do not want to change that anymore. So the other thing that I'm supposed to have in my answer is hours. So I'm going back to my original and I see that minutes are in the denominator. So I need to pull in minutes and I need them to be on the top and I need them to be changed to hours. So 60 minutes to 1 hour. And even though they're not next to each other, minutes at the beginning on the bottom, minutes at the end on the top, they will cancel. Now I have milliliters on top circled, hours on bottom circled, so I have the label that I was asked for, and it's time to do my math. We remember with dimensional analysis, we multiply straight across. So on my calculator, 2 times 104.5 times 250 times 60. And I get a huge number, and that's okay because I'm going to divide by a huge number in the denominator. So I have 3, 1, 3, 5, and 3 zeros. In the denominator, I'm going to multiply 1,000 times 400. And so on my calculator, I get a 4, and then it has 5 zeros. And you just have to be real careful when you're dealing with these big numbers, all these zeros. And so then finally, I can divide that out. So I retype. So 313, 3 zeros divided by 4 and 1, 2, 3, 4, 5 zeros. And I get 7.8375. So I have to think through how to round. This answer is in milliliters per hour. Milliliters per hour are always rounded off to tenths. So 7.8 milliliters per hour. Now, this part was the most work of the entire problem. So we just did the most involved piece. From here, we are going to use what we had in our pre-lecture notes, that dose and rate are proportional. So dose over rate. And I'm going to use that proportion and cross multiply to do much shorter problems. Now, I find it helpful for me to always go back and look at what numbers will I be using. So right here, this 2 micrograms per kilogram per minute, this is my minimum dose. And through the dimensional analysis, that gave me 7.8 milliliters per hour, which is my minimum rate. So I always am going to set up my proportion based on that minimum. So my minimum dose is 2. My minimum rate is 7.8. I put an equal sign, I put my next fraction bar. They're asking me here for the initial pump setting. The initial would be the start. So we recorded up here that we're to start at 5. I'm looking at the label with the 5 and I see that it's micrograms per kilogram per minute, which match the label on the dose. So the 5 goes on the top and the X goes on the bottom. When I solve a proportion, and this is where I have so much thinking going on all at the same time, proportions are solved by cross multiply. So I multiply diagonally, 2x is equal to, and I do on my calculator, 7.8 times 5, and I get 39. And then I divide by 2, and I get x is 19.5. Because that 19.5 matches up with the x, which is in the denominator, that matches up with the rate, and so that is giving me a milliliter per hour number. So I go on to my next question, and it says maximum. So again, I'm going to use my idea of a proportion dose over rate. I'm going to use the minimum, where we had mentioned and circled the minimum dose was 2, the minimum rate 7.8. And the range is what we're focusing on, and the maximum of the range is 20. That has a label with micrograms per kilogram per minute, so that goes on the top. Put my X on the bottom. Now you may notice here 2 times 10 would be 20. And so we can do this shortcut on the bottom as well and multiply times 10. So 7.8 times 10 would give me X is 78 milliliters per hour. Now, if you're uncomfortable with that shortcut, let's actually do the math. So 2 over 7.8 is equal to 20 over X. Cross multiply, so 2X is equal to 20 times 7.8, which my calculator tells me is 156. And then I divide by 2, and I get X is 78, which is the same answer that I got before. So we see that proportionality coming out here, and we see that we've captured it. We talked about it with the first example. Since the range goes from 2 to 20, which is 10 times more, the rate would go from 7.8 to 78, which is 10 times more. So repeated in these problems is using the proportionality concept, and that is where we set up that proportion, dose over rate, always using the minimum. So we're going to continue with that as we look at the chart. So it says at 9 o'clock, we're going with the ordered. So the ordered was to start with 5 micrograms per kilogram per minute. And that was my ordered start when I read the problem. We had on the previous slide did the math, and so that turned out to be, now I forget, so I have to go back. Turned out to be 19.5 milliliters per hour for that initial pump setting. So 19.5 milliliters per hour. And all that was done on the previous slide. So now we are told to adjust up. So we see that 10 minutes has passed. And we're told here, adjust up. So we had written this out on the previous slide, but it's here in the last sentence. So titration, that was the word adjust. That's the meaning of titrate. And it's 2.5, and it's to happen in 10 to 30 minute intervals. So we see the 10 minutes elapse. It's time to adjust up. So to adjust up, I will simply add. So I'm taking 5 plus 2.5 equals 7.5 mcg per kg per minute. I'm going to do the next one as well because I'm just in this column. I'm supposed to adjust up again. So this time I'll take the 7.5, add the 2.5, and I get 10 mcg per kg per minute. Then I need to figure out flow rates. So truly in real life, I would do these one at a time, and I'd have to wait 10 minutes before I make my next adjustment. But here on my chart, I could keep going. So for my flow rates, I'm going to use the idea of dose over rate. I am going to use the values from the minimum. So the minimum dose was 2, and the minimum rate that we calculated was 7.8. And that is equal to our new dose of 7.5. And we want to know a new rate to set on our pump. So we will cross multiply. And so multiplying on our first diagonal, we get 2x. Multiplying on our second diagonal, 7.8 times 7.5 gives me 58.5. And then divide by 2 on both sides. And I have 29.25. But because it is a milliliter per hour, I do have to round it off to tenths, so 29.3 milliliters per hour. And I keep going. I do my last problem the exact same way. So I'm putting dose over rate, which is 2 over 7.8. I put my new dose on the top, which is 10. Put that over x. Again, with this problem, you may notice a shortcut. So 2 times 5 would give me 10. So 7.8 times 5 could give me my answer. And with the help of my calculator, that tells me x is 39 milliliters per hour. But you don't have to know the shortcut. So if you don't notice the shortcut, 2 over 7.8 equals 10 over x. Cross multiply, so 2x equals 78. Divide both sides by 2, and x equals 39 milliliters per hour. And so that finishes out our problem. And so we did dimensional analysis once at the beginning, and then we used the idea that these are proportional and solved the rest using a proportion.